Now let's start the second part of today's lecture. You remember where we were? Yeah? So we were implementing this intro function. Right? You know how to interpret these expressions, and now time for a function call. Before discussing how to implement this function call, we'd like to see some examples so that we can have some idea about how to evaluate it. Then how do we know? Let's try some tests. This test function, it takes this expression and then its expected result. What is that? What is that? This intro function takes three arguments: an expression to evaluate, an environment to look up the values of the names that may be in this expression, and a list of function definitions. FDs, a list of function definitions. This expression is 1 plus 1, and under no environment, nothing, it's an environment, the empty environment. It does not have any mapping for names and values. Oh, empty list, meaning there's no function definitions to look up. Yeah, indeed. 1 plus 1, we do not need to look up the names because there's no name. We do not need to look up the function definitions because there's no function. 1 plus 1 is what? 2. Yeah, you know that. How about this expression? Oh, the same expression 1 plus 1 and the same environment, which is empty. But this time we have one function definition. Oh, until where? 1, 2, 3. 1, 2, 3. Maybe here. Yeah. Then what is that? It's a function definition, function of name f. The parameter name is x, and the body is x plus 3. X plus 3. Okay, whatever it is, we don't call it. In the expression, that's 1 plus 1 again, 2. Yeah. How about this expression? Oh, finally, we are calling function f. So this one, see? Function name, open, expression, close. That's the syntax for function call. Function name, an expression. Function name, an expression. What do we do? Let's see. Oh, yeah. In order to evaluate this function call, there's no names available in the environment, but in the list of function definitions, we have only one function. Yeah. It's function f, parameter x, body is x plus 3. Then, when we have this function call, we need to see which one it is. Oh, yeah, function named f. We need to look up the function definitions from FDs. Yeah, there's only one function definition. Luckily, yeah, just the same name. Then, we are going to pass the argument value 1 to the function parameter. So, when we evaluate the function body, we know that x is 1. Using that information, evaluate the function body, x plus 3. What's the value of x? Look up the environment. Oh, 1. 1 plus 3, which is 4. Now you know how to evaluate function call, right? How about this one? Ooh, now we have two function definitions, function f and function twice. The body of function twice is what? Oh yeah, its primary name is y and the body is y plus y, as usual. On this time, function f is different. Its parameter name is still x, but the body is 20 minus yet another function called twice x. Okay, then. What's the expression to evaluate? That's f10. Okay, in the beginning, we need to look up this function name f. Hey, what is it? This one. Oh, that function definition. Okay. Its parameter name is x. Argument value is 10. Bind it. So now, even when we evaluate this function body, x's value is 10. Remember. Let's evaluate the function body. That's 20 minus yet another function call. Yet another function call? Twice x. What is twice? Look up the function definition. Oh, it's here, right here. Okay, and its parameter name is y. What's the value of y? That's the value of x. What's the value of x? Look up the environment, 10. So we put 10 here. Y is 10. Using that information, evaluate the function body. Y plus y, 10 plus 10, which is 20. So the result of twice x is 20. So the result of 20 minus 20 is 0. 0. Very good. That's how we evaluate function call. Now you know how to evaluate function call, right? How are we going to do that? When we have function call f of f and a. Remember, what's the type of f? What is it for? That's function name. So its type is string. What is a? That's argument expression. Argument expression whose type is expert. Aha. Then we know when it's expert, we are gonna call interp with expert and environment and FDS. We are gonna call interp. We are gonna call interp. For what? Oh, expression. Argument expression A. What's the second argument? Environment. Which environment? This one. Oh yeah, EMV. What's gonna be the third? FS. Where is it? Oh yeah, from here. The past one. So we are gonna evaluate the argument expression under the same environment we got, using the same function list we got, right? Then that's gonna be the value of the argument expression. Then what is f? That should be a function. What's that function? Where do we get it? Oh, we get it from here. Because FDs is a list of function definitions. Right. Just like when we had a name, we looked up the environment by using the name. So we want to look up the function definition by using the name. Oh, that makes sense, right? Yeah. How do you do that? Look up function definition. Oh, very similar, right? Look up the name from the environment. Look up the function name from the list of function definitions. So the type of this function lookup FD, it takes a string for function name, a list of function definitions, F this, right? And from this list of function definitions, we are gonna look for this function name. Yeah, very good. Then what do we expect? We expect a function definition. Very good. So this lookup function definition, it takes a function name and takes a list of function definitions and returns the function definition for this function name. Very good. Do you remember FDs? The list of FDEF, right? That's list of FDEF. What is a list? List is the best data structure. That's the beloved data structure by functional programmers. Any good programmers love list. Why? What is the list? It's either empty or not. It's either nothing, it doesn't have anything, or it has at least one element and the rest. We either say it's rest or head and tail, like that. That's the usual name. So, why do we like it again one more time? Because it is so beautiful in the sense that it's so mathematical, in the sense that they are inductive. Do you see that? Inductive, induction. Empty is the base case. Cons is the inductive case. A list is either empty or not. A list has no element or at least one and possibly more. That's pattern. Because of this induction, because of this inductively defined data structure, we can perform this pattern. Whenever you have some function with an argument of a list, we are gonna do pattern matching on that. Because it's a list, we can ask, hey, are you empty or not? If you're empty, I'm gonna do this thing. If you are not empty, you should have at least one element in the beginning on the head, right? And the rest should be yet another list. I'm looking for the definition of this function name. But if you are empty, it's for sure, it's obvious that you don't have anything, meaning that you don't have any definition for this name. It's an error. If we have at least one element, I'm gonna see, hey, are you the one that I was looking for? 당신은 제가 찾던 그 님이십니까? Are you the one that I was looking for? Then we're gonna be happy. Otherwise, don't panic because we have the rest. We are gonna look up the same name for the remaining thing by using this recursive function. That's a pattern. Whenever you have a list as an argument, you're gonna do this kind of pattern matching for empty or not. For this example, what are we gonna do? Hey, are you empty or not? If we are empty, I know there's no function of name this, it's an error. Just like free identifier error. Yeah, just like that. Free function name, free function name error. If you have at least one element, I'm gonna say, hey, you H, I know your type is FDEF. Why? Because this FDS is a list of FDEF. Do you also remember FDEF? It had three fields. It has three fields. F for function name, X for parameter name, and then B for body expression. So we are going to ask, hey, you, the first function definition, what's your name? H.F. What's your name? Are you the name that I was looking for? Oh, are you the love that I was looking for? Oh, yeah. Ooh, lucky. Then return it as it is. 그분을 찾았어요? 그걸 return해요. Otherwise, yeah, I'm not yet disappointed because we are going to look up the same name from the remaining tail. So far, so good? Okay. Then, now that we know how to use lookup FD function, how are we going to evaluate the function body? Do you see it? Can you see that? Let's see one more time. For function call, we have a function name and argument expression. So we look up the definition, function definition, by using this function name and the list of function definitions. Then we are going to get FDEF. One more time, you know what FDEF is. It has what? Function name, parameter name, and body expression. What can we do? Pattern matching. We are gonna look up the function definitions by using the function name from the function list. Yeah, function list. And because it's gonna return FUNDEF, FDEF. We are gonna do pattern matching. If FS does not have the definition of F, it's gonna throw an error here. Yeah, don't worry. If it has at least one that matches this name, then it's going to return it with the same name F. Yeah, they should be the same. And parameter name and body expression. So that's how we got the definition for this name F. What about this argument expression A? We are going to interpret that argument expression A under the same environment using this function list. Get the value. So now, for example, for that example, twice 10, we looked up the function definition to get the definition of twice. We evaluated argument expression to get the value 10. What's next? What are we supposed to do next? We are going to evaluate the body, right? Yeah. When we have, one more time, twice 10, we looked up the function definition by using the name and evaluate the argument and get the value. Then we are gonna interpret the body. Let's see, it was def twice x equals x plus x. We looked up the definition from the list of function definitions by using name twice. So we got this f of f, whose f name is twice, whose p name is x, whose body is that thingy. And then we evaluate the argument expression a, which is 10. Get the value a val, which is 10. Now let's evaluate the body expression x plus x. Using the same list of function definitions, we never changed the list of function definitions. Oh, we can discuss that later. But we are going to evaluate the body expression using the same function definitions. What about the environment? That's the question, right? What are we going to do? If we don't know, we are going to see some more examples. What are we supposed to do? Let's see. Function calls, right? Let's review one more time. Whenever we learn a new language concept, there's going to be introduction, and use. When we introduce name, there's a name introduction syntax. Open val name equals E1, E2, close, right? This Y is not used. That's not a good example for names, but we have this good use case. Whenever we have new concept function, there's an introduction place, function definition. Use side, function call. So function call is really important because otherwise, why did you define a function? Okay, let's use it. How can we call a function? Yeah, it's gonna be like this. When we interpret this expression, it's a name, introduction, y's value is 2, and then we call function f. Y is not used. That's okay. What is function f? Function f takes one parameter and the body adds 1 to the parameter's value. So far so good? Yeah, not that complex. So let's evaluate this expression under empty environment. Now you know how to evaluate this expression. Evaluate this one, get the value, and remember that y's value is that, meaning y is 2. Put that into this blue box. So yeah, when we are done evaluating this one, y is 2 is in the environment blue box, and then we're going to evaluate function call f10. F's definition is right here by lookup fd. Evaluate the argument expression, the value is 10. Let's evaluate the function body 1 plus x. Let's evaluate the function body 1 plus x under which environment? That was our question before, right? Before, when we were interpreting, write down the evaluation, interpretation of function call, we were wondering what environment we are going to use. Interp body B, and we are going to use function definitions, and what's going to be the environment? That's this question, right? Do you see that? What do you think? In order to evaluate this one, we need to know the value of x. What is x? The parameter. So, interpreting function body requires one piece of information, only one piece of information, which is the value of the parameter, function parameter. Where do you get it? At the function call site. At the function call site, you're going to get the value for the function argument, the function parameter. So far so good. Yay! Then, what if we extend the old environment? What goes wrong if we extend the old environment? What do we mean by that? Let's see. Here, this time, function f takes a parameter x, and the body is y plus x. I know x because that's a parameter. What is y? What is y? I don't know. It's a free identifier error. It's a mistake. Yeah, we made a mistake. So, yeah, anyway, there are many wrong code, wrong programs. Let's run it. So you hope to have runtime error because we don't know the value of y. Let's see. Let's evaluate this expression one more time. From here to there, y is available from there to there. What's the value of y? 2. Let's evaluate f is 10. Okay, before that, y is 2. Remember, okay, before evaluating f function called f, we remember that y is 2. When we evaluate the function body f, which is y plus x, we are going to pass the argument value 10 to the parameter. But do you want to pass this information as well? What do you think? If we are in the same room, same classroom, I'm going to ask you to raise your hand whether you want to keep this one in the function body or not. Because even though I'm going to say this semantics is wrong, that may be too strong. I'm going to come back to this point in a minute. Here, let's see. This time we're going to keep it because we are greedy. 욕심이 많아. Yeah? We have this peaceful, this precious information. Why wouldn't bring it into the function body? Let's see. Then we are going to keep that information. On top of that, we are going to add the new information that x's value is 10, like that. Then when we evaluate the function body, the value of the parameter is 10, which is good, but the value of this free identifier y is 2. Wow. Originally, when we defined this new function, y was free. Not good. But because of this information at the function call site, we got a new piece of information. So it becomes 12, which is wrong. Then what do you expect? Instead of that, when we evaluate this, when we call this wrong function, in the beginning again, the environment is going to be empty. But when we evaluate this expression, y's value is 2, which is good because we wanted to know that information. And then when we call this function f with the argument 10, when we evaluate the function body, we do not want to bring this environment. We just want to bring that information that argument value is 10. That's it. Only that piece of information. Then when we evaluate that wrong function body, what's the value of x? That's 10. What's the value of y? Who knows? I don't know. Free identifier error. So interpreting function body with only one piece of information for this, F1VAE, meaning that other languages may have different environments, like FVAE that we are going to learn later. It's going to have not only one, but more information. Then, why do we want to have this semantics? Is the previous semantics, is that really wrong? Isn't it too strong to say that? You may prefer to have it, right? It's not like one is really good and the other is bad. But actually, keeping this call site information is really not really a good idea. And that was a historical mistake that really famous language had, and really famous people made the mistake. Isn't it crazy? So what is that language? That's Lisp. Lisp is a really famous programming language, and it originally introduced dynamic scoping, but it was an accident. We are going to talk about static scope and dynamic scope after the second break.